We have received a number of questions prior to the session. Like I say, we're going to open it up frequently and say, are there any other questions? And gentlemen, please, and ladies, if you have a question, ask it. This is a good chance to, talk with us. The first question that we had was, what is the first step in training someone to manage grain?
I'm going to lead off with that answer. You have to evaluate the individual knowledge that the person holds, because without understanding this, what? Excuse me. Is that okay? Okay. Turn it up, Tom.
Can you get it closer?
Oh, sorry. You have to evaluate the individual's knowledge. If you don't understand the science behind what the kernel of corn is, or the kernel of grain is going to go through once it's harvested, it's pretty hard to predict what might happen going down the road, and especially when you have to handle all of the characteristics and all of the quality factors that can cause the natural demise of grain. Because once it's harvested, it's never going to gain better quality. And the only way you can really sustain the quality is to lower the moisture, and then you're losing the weight. So it's still losing mass, because all grain is going to go to carbon dioxide, water, and heat energy in some fashion. And the joke I'd like to use is every kernel of grain really wants to go down the pathway to end up in a bottle of spirits. But that's my personal opinion. But if you don't store it right out, in your whatever mode of storage you're using, it's going to go right there on its own in place. And there's the biochemical reaction is going to happen no matter what. It's a living biological material. But then there's the external factors: temperature, humidity, insect activity, molds, fungal activity, all kinds of things, rodents. And then we have controlling actions, and even the controlling actions take away the mass that we're trying to carry forward in storage. So the main thing I'd suggest is that person understands that you're dealing with a biological material that's going to degrade in value as time goes on.
I guess my approach on it has been just to teach them first and foremost why it's important to the bottom line of your location and your business. So let them know what you're doing is important and why. If they don't know that, they may not even listen to you. So we all have examples of what's went wrong, how much money it's cost us. Every company has them. Use them, explain to them. If you ask a stupid question, nobody remembers 5 minutes from now, but you turn 500,000 bushels of beans into dirt. See how long they remember that. So make sure they have a network, make sure they're comfortable asking questions, make sure they know when to ask a question. After that, it's all details.
A couple things I would add into a lot of stuff we've heard many times today, but it never gets any better. But I think a lot of the people that need to hear that is the merchandisers. I worked with one at one time, and he said the whole purpose of a grain elevator is to take bad grain and make it good. Well, you don't take bad grain and ever make it good. You might dilute it and make it look good, but if you got a kernel of heat-damaged corn, there's nothing you can do to it to make it a good kernel. So it's key to that side of the business understands what we all know. And the other thing, I've heard a lot about quality today, but I've never heard a definition of quality. And the one I was taught many years ago was quality is conformance to requirements. So we all sell grain in here to somebody, whether it's another division of our own company or an outside person. It's key that you know what your requirements are. You may have a customer that will take 10% damage. If you can supply that, you're meeting you're meeting their quality. But you may have a customer that doesn't want any. So you need to know that up front. And fortunately, we're in an industry that accepts defects. If you're selling number 2 corn, there's levels of moisture and damage and FM. But, in a lot of businesses, you can't have that. And I think this business is going to get more towards that way. You know, I use the example of the one bad apple. When you go in the grocery store and look for a bag of apples and there's a bad one in there, you're not going to buy it. So as time goes on, I think it's going to be increasingly difficult for us to get rid of our problems by hiding them and blend them and send them down the road. So that's my take.
Thank you. Next question. What is the one most important item that one must do to manage grain and storage?
I guess I'll lead off on that one. In my opinion, it's always been about prep work, and I liken it to painting a room in your house. We all know there's nothing sexy about taping and painting, but if you don't do it, at the end of the day, it's going to look like crap. So there's nothing exciting about cleaning it off and making sure you got it sprayed down and making sure you have your aeration tubes correct and everything's working and your temp cables are working. That's maybe not the exciting part, but if you don't do that up front, everything else may not make any difference.
Yeah, I'd like to add to that. The size of the lot that you're dealing with a lot of times dictates just how comprehensive a storage plan would be, because if you're trying to move 2 or 3 or 4 million bushels out of a mass of grain in a bunker or something like that and it's out of condition, the marketplace just can't handle that kind of volume quickly in order for us to salvage the product. So the plans have to be more complex, I think, and comprehensive, more schedule-oriented and detailed when the risk is that high. So a storage plan for a blending bin during harvest when you're loading trains isn't going to be anything more than a thought, you know, just in a moisture range most likely. But you have to put a lot of thought into the areas where there's large risk.
One thing I would add is get out of the office. I don't know how many times in my career I've prevented catastrophes or found out about catastrophes simply I was out and about at the facilities I was responsible for. It's the old adage, you can't expect what you do not inspect. So when you're out and about, and I heard the thing this morning about communication. Walked out of my office one day and did the old nose, and the gal that spoke earlier said, you know, one of the best determinations of grain quality is right here. And I called her elevator manager and I said, you got some burnt beans, don't you? Yeah. Well, how'd you know that? Well, I smell them. How long have you known about it? Oh, a month. Well, why didn't you tell somebody? Well, I didn't think we could do anything about it because we were full. And it goes back to, I believe, what Nick was up there with you? You know, if you make everybody aware of a problem, it's our problem. If you keep it to yourself, it's your problem. And when I have a problem, I like everybody in the room pissing out instead of outside pissing in.
I have one other thing to add. I'd like the comment, but one other thing to add. This year, when you look at the size of this crop and just the timing and it's going to come off in harvest, we're all going to have to face probably the certainty that we don't have enough storage. Even with our temporary storage and emergency spaces, this might be the year that, like I believe it was 06, that was just so large and so wet we couldn't handle it, and everybody panicked and threw grain on the ground thinking they could dry their way out. We're going to have to face how to maintain the quality this year, because I think it's setting up for that size of bumper crop, and it'll all depend on how the weather goes in the last few weeks of the development of in the dry down of the corn. But I'm going to talk about corn because I always worry about that a little more than most other grains. But this is a year we're all going to have a plan in place, or we're going to face some real risk.
Okay. What causes you to be concerned when you look at temperature cable readings?
I'll start off on that one. You know, obviously, if you get sudden drastic changes and normally increases, I've never gotten too worried about decreases. But something I always looked at in the maintenance background was if you looked at cables and every temperature on a particular cable was the same. or you had 4 or 5 cables, every temperature is the same, always makes me wonder what's wrong. Are thermocouples tied together or cables tied together? I've seen it before. So, when you're doing, you have to maintain and inspect temperature systems just like any other piece of equipment. They will tell you if something's wrong, but you got to know what to look for.
Yeah, and I'd say sudden temperature increases as well. Being through several Kansas wheat harvests, if you've got recently harvested wheat that's 97 degrees, that's far less concerning to me than grain that's 80 that was 70 last week. So it's that change in temperature that you have to watch out for.
And another thing to add, if you have tactics to deal with conditions that develop in the bins or whatever the storage mass is, and you try your tactics, it might be air or whatever, another opening up different airflow through a bunker, something of that nature. And if you don't get the results you want, then looking at those temperatures not changing should add another level of urgency about what's going on in that mass.
I think I'll open up this time. Does anybody have a question they want to ask? Rather than just listen to us. Yes, Dave.
How important are top ventilation fans?
In my mind, very important, and I'll share a story with you. Years ago, we were getting grain rejected at a facility due to blue-eyed mold, and I asked the facility man, well, what's your problem? Well, all my temperatures are good, everything looks good. Well, where's it coming from? Well, we just started pulling out this 2 million bushel bin, and it's coming off the top. Well, have you been up there and looked at it? No. So I said, well, go up and look and send me a sample. So he sent me a sample, and you could obviously see it. And this bin had push aeration. I said, well, do you run your roof exhausters? Well, we have 5 up there, and 3 of them are broke, and we couldn't fix them, so we just quit using the other 2. So I think the proof is in the pudding there.
Yeah, if you've got push aeration, they're critical. Your moisture will go up to the top, it'll condense out, and next thing you know, it's raining inside of your bin. The other thing that ends up happening is you have condensation on your sidewalls, and bin manufacturing engineers have told me if they're not worried about the water, they're worried about the mold in the grain. That's what actually, in a steel bin, that's what deteriorates the interior of the steel bin. So you get that moisture, you get mold, and it's stuck on the sidewall of your steel bin. That's the beginning of your steel bin deteriorating. So getting that moisture out of there once it's pushed through the grain mass is absolutely imperative.
And also this morning, Nick mentioned that he showed a slide of the grain bin having airflow without fans running. The ductwork might not be capped off, but there's still a natural flow of air, and the condensation would still form at the top even without a push-up air situation. And once the heat starts, it's just going to build more and more humid air to go to the top and condensate out. So you got to have them in all cases.
And one other thing I add is location of roof fans is just as critical as their operation, because if you put them in the wrong place, they won't do any good, or they will do minimal good.
The thing I'd like to add, key off, they've talked about inspect your bins regularly, get out of the office, look in there. The top fans, in my opinion, are very, very important. If you open up the lid and there is moisture, there is mold, suggests something going on. I mean, there's some aeration people here that can support this, but a lot of times contractors will cheapen up the cost of the project by not putting any power vents on. They think all you want is cheap, where really what we want is something that works. And I think the rule of thumb was, since you're taking air and introducing it through the mass of grain, it's picking up moisture, it gets heavier. So it's harder to evacuate it out the top. And I think the number was 150% of the CFMs need to be on the top is what's going in. Otherwise, you're just creating this problem. I see Scott nodding, and he knows more about aeration than I do, so it must be okay.
I was going to add one more scenario that happened at one of my locations. You don't normally think about flat storage and wheat storage as being a potential problem for that condensation issue. Well, it sure was for 1 million bushels that I was responsible for, and it had to do with insect activity that was unchecked. It led to the heat, and then we walked into the area, and it was raining inside. It was the roof. There was a nice line of drops right along with the rafters in the roof. You can't take wheat for granted, can't take any space like that for granted. It's not just bins. All spaces, that'll happen.
Another question we've had fed to us earlier was, what do you feel is the appropriate CFM of aeration that you need to have for long-term storage?
The old rule of thumb that I've used since Professor Wayne Sanders of Boone Aeration started teaching me back 30-some years ago was 1/10 CFM per bushel. I've found that to be satisfactory. I've had good results with less. I would not put less in. Sometimes you would need more depending on how much time you got to work with. And some areas of the country you don't have much cool weather, so you need to aerate very quickly. So you would need more then. But I have found in older tanks, that were built 20, 30 years ago, the level of aeration expertise did not exist back then like it does today. So a lot of older tanks do not have the available screen area to deliver that type of aeration. So you may have to go back and retrofit tanks to get that.
I've always shot for 1/10 CFM on design too. You get much more than that. You're talking about drying grain. If that's what you're trying to do, then that's great. Leaving fans on moisture is going out those fans too, and moisture is money. So yeah, you got to keep track of that too. If you've got a superintendent or somebody locally that just likes to turn the fans on and leave them on and start shipping 15-0 trains at 12-0, you just lost money. So you got to keep that in mind as well. The other thing I would encourage people to do is figure out what the calculations are on CFM. I was amazed the last couple times I've called companies asking them what aeration I need on the same exact bin. I got 3 very different answers. So horsepower ranges that were huge. So just know the math. You don't necessarily have to be an expert, but I'd encourage you to at least be snow-proof. Know when they're lying to you, or just don't know themselves. Well, we won't call it lying.
Yeah.
That's covered.
Next question is, what sort of record-keeping systems do you suggest?
You want to start with the planning, documentation of the planning that goes into setting up for any harvest or any long-term storage logistics at your plant. So you need to document that as a good baseline, and then start to receive the grain. And it's not just the first set of temperature readings and off the cables or any other types of readings, but you might send in samples. Good practice to send in samples for mold that comes right out of the field. Sometimes the grain comes out of the field in a condition with mold count that if you're going to have a tough recovery on it, like a bunker, it takes a long time and it's going to be exposed to warm air. That's going to put you in a position with a lot of blue eye mold potential when you do reclaim the grain. So I like to start that process when the grain's going down and you got good access to samples. But then also the best systems seem to be those that are automated. You can do the testing and monitoring of indicators in a good frequency where you can use the data to develop sort of a visual look at what's going on with the space. And it just seems a lot easier if you do it with a good computer program and it has some kind of a visual result that you can look at. It just gives you a different sense of what's really happening in the grain mass. But easily viewable, consistent data retrieval and documentation, and also specific to the real indicators that you want to measure that have the greatest value. That makes sense? If you get in trouble, blow the whistle.
Certainly temperature logs are critical. You have to have that to be able to pick up if there's a trend going on in a given bin. It's something that's happening over time. It could indicate, here again, grain starting to go out of condition. And I've always liked not only just temperature logs, but at least part of the maintenance program to maintain ohm readings as well in a log. I've always felt the ohms were kind of a fingerprint of a given cable, and they could tell you if there's a maintenance issue with a cable, or a cable's wired up backwards, or something like that as well. And I've always recommended aeration logs as well. Aeration is one of my pet peeves. And I always feel at the beginning, every time you clean out a tank, you should do empty static pressures on your fans to see are screens getting stopped up, or did somebody put a fan on and put it on backwards? So that can tell you if you got a problem before you fill the bin, when it's easily corrected, and then go back after your bin is full and get static pressures then to see. You may have a fan that was designed for corn, and you've got wheat in the bin, and you're getting little to no air. And one of my old sayings is horsepower plus noise does not equal good air.
I got nothing.
I think we heard this morning in an earlier session Corey put on about accident investigation. The record keeping, what it does is allows you, if there is a problem with the quality of the grain, you can go back and look at the details and the information you assembled and say, okay, what probably caused this? Give you a chance to maybe adapt something different the next time. So I really feel it's very important. So.
I guess I will add, too, one thing that's helped me in the past is just keeping a history of not just what happened this year, but what happened in the past when it went wrong. I've been in situations where, short memories, 3 years ago, we had to blend out a bunch of damaged wheat, and now the VP and the merchandiser wants us to hold it even though I know it's going bad. And well, this is what happened last time. He sent me an email saying, you're taking responsibility, I'll hold it, otherwise we're shipping it. And lo and behold, we were shipping it. So having those records to show them the bottom line impact and remember when can really pay off for you.
And that comes to help when you have a lot of people moving around location to location, because you get a bunch of new guys in, they don't know what happened 3 years ago.
Yep.
And they can rely on that a lot.
Thanks, Tracy. Next one. How much variance in moisture content do you feel comfortable in binning in the same bin?
Well, a lot of times it depends on your logistics at the plant, how many bins you have, what size of bins. That's a good starting point. It's really what you're going to try to have as an outcome loading out, and can you maintain quality and not lose a lot of weight storing that grain before you load out. At the end, you always want to be able to load out what's in the bin. So the highest moisture of any range would be that quality, that moisture level that'll make grade with the blend, but not lose quality. And the lower range is going to be a logistics and sometimes an economic decision on how your plant's set up. But the main thing is probably 2 to 3% is probably pretty normal for most bins. Sometimes you might have 5%. But you're always forced into some bad choices. If you have one wet bin and you've got 20 moisture corn, let's say, and 32 moisture corn in there, and that yo-yos up and down with harvest, that's going to be a hell of a bin to dry. And parts of that bin, if they're not pulled out quickly, are going to start to go bad within a day, that 30 moisture stuff. They don't have a shelf life. That grain does not have shelf life at those levels. So you got to be real careful even ahead of the dryer, assuming that you can go a week or two on, some wet bins. But for long-term storage, I don't know, 2 to 3%, whatever your plant will yield with the number of bins you have, it's probably a decent range. Whatever facilitates good line blending going out. With some grains a little different though. Like with soybeans, you could probably go 5%. Because it seems the beans seem to transfer that moisture bean to bean by touch, and it's sort of an odd thing. But 2 to 3% probably be where I would be with that. And of course, there's always that scenario like last year. Almost all the grain came in at 14.5, let's say for corn. Well, if you don't have anything to blend that's higher moisture, it doesn't really matter which bin you put it in that case. So then the numbers sort of go out the window. But what do you guys think?
That about covers it.
Again?
Yeah, you're doing good.
Thank you. Anybody got a question in the audience? Yes, Scott.
Blending, or not, sorry, coring a tank. What are your coring practices at your facilities after you fill?
Long-term storage, let's use let's just say 2 months as a storage window. You'd want to core those tanks in probably 15 or 20% of the volume of the tank to get the whole core out, then blend that off with normal
Put it
load.
back into the same bin? Or
Oh, no. Just keep it separate and try to blend it off. Leave that tank in a good position for air to move through the mass, and if you pull the core, you'll have a good chance to move the air through that mass in 2 months.
15 to 20%, if I heard you correctly,
Of the volume.
of volume.
Yeah, at least. Yeah.
At least.
I'll tell you one story, and he knows about the tank. Few of you fellas know about the tank. I went to the facility. It was a 1 million bushel bean tank. Hell of a time getting the last of it to flow, and we're getting some black chunks out of the bottom. And I crawled up on top of that big steel tank and looked down, and it looked like 2 or 3 oil cars stacked on end, standing straight up. And it was just the spout line that had turned solid black. Now that tank probably needed to have 200,000 pulled to pull it all out, for safe long-term storage. It's a big deal to get that spout line out, especially with soybeans, because the seeds seem to be pretty darn wet.
Adding on to, certainly coring is critical. Any of you that heard me give my aeration presentation at Jeeps, you can't push air through dirt. It just won't go. And I've always found, as tanks get bigger today, 500,000 and 1 million bushel, 1.5 million bushel tanks are the norm. I always felt you need to core in stages. So if you got a 1 million bushel tank, if you can do it, draw a core out at 250,000 bushels of fill, and then once you get to 500,000, pull some more out, and it keeps that center broke up. You don't have all those fines to deal with at one time. You can kind of meter them out. Years ago, Purdue's biggest customers ourselves, the poultry division. Years ago, we just sent that stuff to the feed mill and let them work with it. Well, we can't do that anymore. We have to blend it and make grade, and because our own company will reject our own grain. So it's a different deal today. But it's critical.
And when coring, you have to keep in mind kind of how a bin unloads to approximately 3 times the diameter its center unloads. After that, it's en masse. So if you've got a 120-foot bin that's 30 foot in diameter, the top 30 feet is just going to move in mass. It's not going to center core anymore. So you haven't cored that last 30 feet till you've got it below 90. So kind of understanding that to get that out of there.
And I've seen tanks built with the center draw not in the center. So
Center-ish draw.
Center-ish, yes. We had a 600,000 bushel tank that we had to pull almost half of it out to get the core. And we kept scratching our heads, why did we have to pull so much? Come to find out the center draw was 20 feet off center.
Tony, I think you had your hand
Saw a
up.
question up there somewhere.
The guy on the left, you said I kind of,
I think he's talking about the depth and diameter, is what you were talking about.
The guy on his left or your left, Jeff?
This one?
That one.
Yeah, this one.
And your other left. You?
As far as the en masse, and kind of a general rule of thumb is that about 3 times the diameter, it'll center core. After that, the grain just moves in mass. And if you actually watch a bin, I've watched a bin unload to see if it's true or not, and you really don't see the center core out until you get down to about 3 times the diameter. So that top grain does not move. It just moves in mass, and then the core itself doesn't start folding in on itself until in the neighborhood of 3 times the diameter. So you can end up with a core 60 feet or 90 feet down, 100 feet down, because you think you cored it, and all you ended up doing was moving a problem spot 20, 30 feet down. Yeah, and how fast you pull, how big your gate is will make a difference as well. But
so coring it with at 250 or 500 or 750,000 or whatever, that helps prevent
That's what we found, yes.
And Tony, just so you heard him say, if it's a 30-foot diameter and it's 120 foot tall, you're going to core the 90 feet until you get the whole mass down to 90 feet. So, Bob, I think you had a question, didn't you? I see your hand. Or did you get
No,
answered?
he answered it.
Okay.
Michael answered it relative to the multiple cores on the
Okay.
larger bends and so forth.
Good. Corey.
You really can't core too much, but you can core too little is kind of the key. So
Are there different principles for storing grain in temporary storage versus a regular tank or
yeah, absolutely, because generally a temporary storage you can't get it out as fast. If you've got a 1 million bushel ground pile and 2 million bushel ground pile, and you got a problem in the center, it's always at the tower. It's going to take you a long time to get to it. If you got a bin, you can just turn, or you're shipping shuttles all the time, and it's not going to be there very long. You got a lot more leeway with that.
A lot of the temporary storage, probably, I would say in the high 90% range is under negative pressure, holding down a tarp to keep the rain water away from the grain. So there's a good example of a lot of air that doesn't do a lot of good. It doesn't actually condition grain, and it is a little different. I don't know how many folks with their bunkers would take the replacement air just that freshens up the mass right under the tarp and run it down the length of the peak. That way the entire peak gets a little bit of fresh air, not just the crossing pieces of ductwork that allow that air in. I've had bunkers where every place where the little 6-inch pipe crossed the peak, it was in great shape. Halfway between that one and the next pipe, it was crusted 2 to 3 feet and really heating up hot. So airflow is completely different in temporary storage. It's under that negative pressure where you're holding a tarp. Totally different ballgame there. It's characteristics of the type of structure you're trying to store in, you know. We're using a lot of tubes these days, just filling the ground tubes. They look like silage tubes, I guess. There's no airflow in those. You know, you better have your mold right, your moisture's right, because you're going to stuff a sausage that's going to be in bad shape here if it goes in bad condition. Little different story with open flats where you can actually access the top of the grain, get a little bit different airflow characteristic, a little more free-flowing through the mass. And then you can stir the top and evacuate all the humidity.
And you generally just have better coverage of temperature cables in a bin. You're going to have a cable every so often in a ground pile. You might have one every 20 feet. And grain's an excellent insulator, so it only reads about maybe 6 feet out. So you don't really know. You're getting a general idea what's going on in there. So. And that's where smelling the air is something that everybody thought I was an idiot doing it, but it's really paid off sometimes. You can smell burnt grain, you can smell weevils in your wheat, you can smell that stuff, and you know exactly where it's at.
I'll give you another example of the old get out of the office adage. We had a 500,000 bushel pile of soybeans under a tarp. Fortunately, they were on blacktop. And had four aeration runs, 4 fans, and 4 of the plastic pipe. Neither one of the 4 fans were installed correctly. They were running, they were making a lot of noise, but they were not moving air because they were inline centrifugal fans, and the guy that put them in didn't think the inlet cone needed to be in there.
Okay. How long do you feel that you can store 18% corn?
Without aeration, and let's say it's 80 degrees, I'll just tell you, there's a ton of science on this subject. Everybody's got a little phone. You can look it up. There's all kinds of studies, Iowa State, Purdue. Everybody has done the same studies. It's time proven. And I'll use this example. At 80-degree air, no aeration, that grain is at 18 moisture is going to start to decompose it in about 10 days. 7 to 10 days, you're going to start to see the problem. Now, if it's 40-degree air or lower, you can go 6 to 8 months because you put a condition in place where the grain will not decompose as well. If you freeze that grain and maintain it in a frozen state, you could probably keep it for years. You'll probably have some drier what do you call it, freezer burn on your corn. You'll lose weight in that condition also. But the charts that are out there, Scott showed me a chart yesterday that he had in his computer, and it's very linear, I would say. And you can look up what your moisture is, how long, what the temperatures are, and with no other outside factors, just the self-reduction of the grain will dictate. It's all in straight relationships. It's very easy to predict. But 18 moisture, I'll just tell you, I used 06 as an example of a very wet year where we got burned on some big storage spaces because we couldn't handle it all, took too much risk. But then we also had 6 months after that. In the colder parts of the winter, we were still receiving 18 to 20 moisture corn in large quantities. And we froze that stuff and actually utilized that corn all the way out into July. And we were actually, from the farm, getting samples in June at 20 moisture. And they were in good shape because they were all frozen down. So it's all usually temperature related in that case.
Those charts they've been mentioning, allowable storage timetables, if you read it, if you screw up and put it into condition it deteriorates, you might lose half of its life. So if you look at the chart, it says 14% can store for 400 days. Well, if you ruin half of it and you take it through the dryer and bring it 14%, it might only live for 200 days. So understand the principles behind it. Very good information there. Next question. Do you use the same storage and aeration principles apply for both corn and beans?
I've found generally they do. You need to do the same thing. Coring is very critical. We've already discussed that situation before. Aeration, static pressure loss through corn and beans are about the same, so not much difference there. Over the years, though, we've had more trouble with beans than corn. I can count on my hands a lot more issues with burnt beans than I can with burnt corn. I was trying to think of some reasons for that this morning. One, I think, is the higher oil content in beans, just like canola. Those of us that deal with canola, very high in oil seed, and the rule there is canola will go out of condition fast, within a day or two. We dry a lot of our beans before we put them away for future processing, so they go in the bin at 11%. I think that low moisture is a false sense of security that 11% beans aren't going to go bad. Well, they will if you don't core and do all the other stuff. And, beans will pick up moisture in a hurry. You can certainly see them come, beans one day coming down the field may be 10%, and the weather changes and the wind changes direction, and 2 days later they're 14%. They'll do the same thing in a tank if you're running fans with the rain on. So I think you have to pay more attention to them, but that's been my experience.
The other thing with beans is just the tighter tolerance. I mean, you can have a lot more damaged corn and not get a discount on the outbound versus beans, and there's just a lot more money involved. So it gets noticed. It's noticeable to your bottom line a lot quicker. So it needs more attention.
And sometimes I think, people will equate corn and beans on moisture. We know corn is considered dry at 15.5, and people will think beans are the same way, even though they're 13. And so, we can put 15.5 or 16% corn away, so we can do the same thing with beans. Well, I wouldn't recommend that for long term.
I agree with that. I was given an example earlier of using having a large variance between the moisture levels in beans, and that's okay as long as they're blended sort of evenly. If you put a 15 moisture bean truck in the middle of 10 moisture trucks, that middle of that bin might just heat up on its own and then lead to other bigger problems. So that's reflects more of a blended condition, and probably not set for long-term storage, really.
But Jeff, you'll see that in all grains. You get them segregated right, then it's a whole lot easier to manage it. You know, if you're putting a big damage load in the middle of a good bin, then you're creating a potential hot spot that's going to grow later, going to be a big headache later. You know, just getting them segregated will stop a lot of your problems down the road. Get them separated right.
Easier to control.
Yeah. It's easier to manage a 100,000 bushel bin of problem instead of 500,000.
Any other questions from the floor before I move on? Chris?
What is the frequency that you actually inspect the grain?
You know, I think up front, it kind of depends on what you're putting in there and what your history is with that storage space, how many problems have you had. Up front, I like to do it as much as daily, take temperatures, go around and smell the air if you have to, make sure everything's working. Once you get a good idea, then you can back it off to whenever you're comfortable that it's normalized. I'm always a little dubious when a merchandiser tells me we're only going to hold it till December. I guarantee it. And then in December they tell me, well, the market's paying me to hold it to June. Well, that's what we're here for. We're here to make money. So if the market's telling me to hold it, then we're going to hold it. And we got to plan for that ahead of time, regardless of what somebody tells you. If we don't do that, we're not doing our job.